even we cannot think of. For example, last day the question comes, describe the layers of the retina. Actually, we don't think it is a must-know zone and don't usually give importance to the layers of the retina, but still it has come. What today I will tell you, actually I just within 10 minutes I finished this chapter, but the question comes. So that you must read the competencies in your book in the first part. What are the competencies, and you must prepare yourself accordingly. In every part of the competency, the question may come. Actually, questions making is now easy. Just they read the competencies and from them put the questions. So, but there is a difficulty for you. But at least you must remember the questions are divided into 3 headings in your chapter. The must-know zone, the common question, for example, what I have told you, the axillary lymph nodes, veins of the superior extremity, the axilla, these are the must-know zone. Then, better to know zone. It is better to know zone. For example, the palmar spaces, fascia, lumbricals is the better to know zone. And nice to know zone. There is the layers of the retina and other. And it has been customarily divided that from the must-know zone, about 60 to 70% will come, but 60%. From better to know zone, 25%, and rest from the nice to know zone. So in this way question comes. So to get the pass, you have to read the must-know zone chapter, and to get a good marks, better to know zone and nice to know zone parts. So it is must-know zone, but I've told today. How do you know that is a must-know zone and better to know zone? If you follow the competency chart, you will find on the possibly in the 4th column NY. Y means must-know zone, yes. No nice to know zone. It is in your curriculum, but question may come, but in only 10% of your question. Already you know, meiosis is very important. Already it is a reduction division and divided into 2 parts, meiosis 1 and meiosis 2. In meiosis 1, after the end of the meiosis 1, the number of chromosomes become half. We call haploid, reduction division, and it has got this is the phase, diplotin phase. It is within the prophase, must remember. After the meiosis 1, you will start the meiosis 2, where it is nothing but like the mitosis. The haploid chromosome become haploid, but the cell divides like a mitosis. So after meiosis 1, 46 chromosomes become 23 in each cell, and after meiosis 2, in each cell 23 chromosomes remain as a 23. Clear? It will be recovered. This is the uterus, you know. This is the body of the uterus, and this is the fallopian tube or uterine tube. And this part of the fallopian tube we call ampulla. Fallopian tube has got 4 parts. From there, this part we call infundibulum, then ampulla, then isthmus, and then a part present within the uterus we call intramural part. And this part is very important is known as the ampulla, slightly dilated part where the fertilization takes place. And uterus, this is the uterus. Body of the uterus, this is the cervix. So look, this is the ampulla, infundibulum, the ampulla, isthmus and intramural part. And it is the wall of the uterus, thick uterus. It has got a 3 layers, outside fibrous layer, connective tissue called perimetrium, and this is the muscle layer called myometrium, and most inner part towards the cavity, here's the uterine cavity. It is the endometrium. It is known as the endometrium. Endometrium has got again 3 components: stratum compactum, stratum spongiosum and stratum basalis. You don't record. Only thing you know, the innermost part of the uterus is the endometrium. Where the implantation of the blastocyst takes place. The fetal develops here. Now, the most important part that comes into your question possibly, oogenesis and spermatogenesis. You know, in our chromosome, for 46 chromosome, there are 44 chromosome we call autosomes, and rest either XX or XY we call sex chromosome. In male, it is an X and Y. In female, it is XX. Right? In your body. These 44 chromosome is present in all the cells, somatic cells in our body, except the sex cells. That means sperm or ovum. In the sex cell, these chromosomes, 44, I am really sorry. In every cell, 46 chromosomes are present, right? 46 chromosomes are present, and out of 46 chromosomes, 44 are called autosomes, and rest 2 are called sex chromosome. In case of a male, it is X and Y. In case of a female, it is X and X. In sex cell, that means mature sperm, mature sperm and mature ovum, it is 22 plus X or 22 plus X or 22 plus Y. In female, it is always 22 plus X ova. But in sperm, maybe 22 plus X or 22 plus Y. Some sperm are 22 plus X, some are 22 plus Y. Next, we go into the spermatogenesis or oogenesis. First, I covered the spermatogenesis. Oogenesis টাই করে নিই. You know, the sex glands in our body is the primary sex glands in our body is the ovary, where the sex cells are present. Now the question is, when the first sex cell appear in you, in us? First sex cells appear when you are in your mother's womb. in embryonic period. At the 4th week of intrauterine life, the first sex cells we call PGC, primordial germ cell, primordial germ cell in you, in me, first appear in your 4th week of intrauterine life. Next line. All of your body develop from, I will come just an inner cell mass, which is now divided into 3 layers, epiblast and hypoblast. I will come, it will be sometimes hard to you now, but still, in your all the structures, the skin, the viscera, etc. Epiblast layer, first hypoblast layer, 2 layers. Then it becomes 3 layers. The mesoderm is introduced. From the epiblast, ectoderm and mesoderm, and then from the hypoblast, the endoderm develops. But it is the old view. Nowadays, it has been proved that all the layers, ectoderm, mesoderm, endoderm, all develops from the epiblast. Previously, এটা জোরে বলছি এই কারণে important. It has been found, it has been assumed that the primordial germ cell, the first cell in our first cell in our body, develops from the endoderm. But nowadays it has been proved that it is developed from the epiblast. So epiblast layer is important. What is epiblast? What is hypoblast? I will come just after 1 or 2 days. শুধু এখানে নোট লিখে দাও, যদি পুরনো বই পড়ো, it will be wrong, important in MCQ. The primordial germ cell develop from the epiblast layer. Epiblast layer is gradually, in fetus, like you look like that. Once upon a time, the early period, you will look like that. This is the head region, this is the neck, and this is the yolk sac, where in the early part we derive nutrition. Like these primordial germ cell developed from the epiblast gradually migrates, come in the wall of the yolk sac. When at about 4th week of intrauterine life, 1 month, at the end of 4th week of intrauterine life, this primordial germ cell, this color comes in the wall of the yolk sac. Gradually, by amoeboid movements, like a amoeba, it gradually moves inside and goes to the wall of the gut. This is the gastrointestinal tract, fetal developing gastrointestinal tract. And fetal gastrointestinal tract hangs from the posterior wall by a fold of coelomic epithelium. Later it develops the peritoneum, the mesentery. Gradually comes to the gut, and through that mesentery, this cell gradually lodge in the posterior wall along with few cells of the coelomic epithelium. It forms the first gonads, either testis or ovary. And this takes about 2 weeks. At the end of 4 to 6 weeks, At the end of 6 weeks, it comes in the primitive gonad. It will form in the posterior wall, in the lumbar region, here, inside, the gonads, right? In case of a male, first gonads develop within the abdomen. Female also remain within the abdomen, in the posterior abdominal wall. Gradually, male gonads, when born, it comes into the scrotum, but female gonads slightly descend and remains in the pelvic cavity. So, this primordial germ cell comes to reside in this primitive gonad, which will ultimately develop ovary. In case of a female, right? So, ovary te ki royeche? The primordial germ cell plus some stromal cell developed from the coelomic epithelium and other connective tissue. তাহলে এখানে প্রিমিটিভ ওভারিতে কি রয়েছে? Primordial germ cell and some connective tissue cell surrounding this the ovary. And this is the primordial germ cell. What is the chromosome number of primordial germ cell? 46. Though it lodges in the ovary, the number is still 46. Gradually, the embryo is growing up. This is known as the primordial germ cell. (46) chromosome. Gradually, it undergoes repeated mitosis, repeated cell division, repeated mitosis. Number of multiple cells are produced. Number of chromosomes, 46. Gradually goes on. At about 5th to 7th month, এবার মাসে চলে গেলাম, 5th to 7th month, the number of the primordial germ cell at the end of 5th month is 7 million. 70 লক্ষ, 7 million. Primordial germ cell. Ultimately, from the 5th month onwards, there are certain changes. Each primordial germ cell gradually converts into a specific cell. Name is gradually changes. Gradually changes, and we call primary oocyte. In female, the term is at about 5th month and 7th month, this primordial germ cell, একটু ভুল বলেছি আমি, it becomes oogonia. It becomes oogonia. Some primordial germ cell, just have an idea. They are in our body. The first slide, I purposefully এই আইডিয়াটা না দিলে হবে না, খুব ইন্টারেস্টিং। There are cells in our body, different cell. We name this different cell. এটা একটু পড়ো, totipotent, pluripotent, multipotent, and multipotent and specific. Totipotent is this cell which can convert to any cell in our body. Totipotent is cell. It can convert to any cell in our body. For example, blastocyst. Blastocyst cell, asbo it can change to produce skin, muscles, bones, embryonic every part, plus non-embryonic part. In your fetus develop, it has got, the fetus plus placenta. Placenta আছে তো? হ্যাঁ? Placenta নাম শুনেছো তো? হ্যাঁ? Placenta is not a partly embryonic, partly non-embryonic. কিছু পার্ট রয়েছে যারা এমব্রিওতে ডেভেলপ করতে পারে না। সো প্ল্যাসেন্টা amnion, chorion আসবো আমরা, it is a non-embryonic cell. It does not form the embryo. So totipotent are cells which can stimulate it, can produce some cell when required, embryonic cell, muscle, skin, stomach, anything. Plus it can form placenta also. So we call it totipotent, totally potent cell. Next is a pluripotent. Pluripotent arektu specific hoye gelo. These cell, some cells of the pluripotent only from embryonic part. They cannot produce the non-embryonic part, amnion, chorion, etc. But some totipotent cell which produce chorion and amnion, part of placenta, cannot produce embryo. They can produce everything about the embryo. Next, the multipotent. Multipotent is a part which are more specific. Multipotent, for example, from the ectoderm, by ectoderm, only the ectodermal cells, skin, etc. will form. From the mesoderm, only mesodermal cells they form. So we call it multipotent cell. Tale, primordial germ cell is a pluripotent cell. Then it formed at about 5th hour, oogonia, which is a multipotent. Oogonia only, it is a multipotent cell. Oogonia only form ovum, no other cell. So it become at about 5th month, this primordial germ cell gradually converted, we call it oogonia. Oogonia. Of oogonia at about 5th to 7th month increases to 7 million. 7 million. Now, gradually, oogonia changes into a, then after 7th month, the destruction begins. Destruction of the oogonia begins. Not all oogonia will be recovered. So, many oogonia gradually dies. Right? Many oogonia just before, after the 7th month, এইবার important. বাকিগুলি শুনে, তাহলে এখন কে রয়েছে ওভারিতে? At about 7th month, oogonia. কেমন? But number is after 7th month gradually decreasing. Gradually, after 7th month, this oogonia, suppose this is the cell, nucleus, আগেই বলেছি, ওভারিতে primordial germ cell রয়েছে, plus supporting cell রয়েছে. Some supporting cells give a covering of the oogonia, flat, squamous type of cell. Other stromal cell. It is a flat cell which covers the oogonia. We call it, this flat cell, follicular cell. We call it follicular cell. Ki boli? Follicular cell. So these are the follicular cell. Come on. And it is the primary or oogonia. Gradually this oogonia converted into primary oocyte. এবার নামটা চেঞ্জ করে দিলাম, বললাম প্রাইমারি oocyte. কি বলছি? প্রাইমারি ও means related to ovary, site means cell, primary oocyte. এখানে oocyte যখন লিখবে, এখানে দুটো ডট মারবে, oocyte. And primary oocyte, one cell with surrounding follicular cell, we call primordial follicle. We call primordial follicle. এবার ছবি দেখ, নাহলে দেরি হয়ে যাচ্ছে আনতে। So this is the primordial follicle, right? And baby is born with primordial follicle. But most of the oogonia now dies. Only 40,000 remains. কোথায় 7 million? Only 40,000 remains. Sorry, only 80,000 remains. আমি ভুল বলেছি। এইবারে এখানটায় ভ্যারিয়েশন আছে। In some books, Langman, it has been written only 80,000 remains. But in some other books, about 1 to 2 million remains there. But Langman is an authenticated book. So, at the time of birth, number of primary follicle is 80 million, 80,000. Repeat, at the time of birth, number of primordial follicle is 80,000. Now tell me what is primordial follicle? বলো। 1 plus 1 এভাবে বলো। প্রাইমারি oocyte প্লাস ফলিকুলার সেল। ফলিকুলার সেলের টাইপটা কি? কলামনার, কিউবোডিয়াল অর স্কোয়ামাস? ভেরি গুড, বুঝে গেছি, গেল। এইখানে যেটা আরেকটা ঘটনা ঘটেছে, জাস্ট আফটার বিফোর বার্থ, when it become primary oocyte, it starts its first meiotic division, meiosis 1, haploid division, গেল। But it is arrested, meiosis division আগেই বলেছি, প্রোফেজ, মেটাফেজ, এনোফেজ, টেলোফেজ আছে। But it is arrested, বন্ধ হয়ে গেল। যেই প্রোফেজের লাস্ট বাট ওয়ান স্টেজে এলো, ডিপ্লোটিন ফেজ, সেইখানে ও অ্যারেস্ট হয়ে বসে রইল, আর পড়বো না কিছু। So, at the time of birth, primordial follicle is born with a primary oocyte arrested in the prophase 1 of the meiosis 1. বুঝতে পেরেছো? The number of chromosomes still become 46. এখনো ভাগ হয়নি। At the end of meiosis 1, it will be half. Arrest হয়ে রইল। কতদিন অ্যারেস্ট হয়ে থাকতে পারে? Prolong. Some completes their meiosis 1 at the time of puberty. Some complete their meiosis 1 at the end, just before menopause, 40 to 50 years. ওইখানে অ্যারেস্ট হয়ে রইল। অ্যারেস্ট, বাড়তে সব অ্যারেস্ট। গ্র্যাজুয়ালি দ্য ফিমেল বেবি বিকাম চাইল্ড, child becomes young, and at the time of puberty starts the ovulation. And during the period of birth to puberty, many of the 1 million or 80,000 million of the primordial follicle destroyed. So at the time of puberty, only 40,000 of the primordial follicle remains. কোথায় 7 million, কোথায় 40,000? কখন? At the time of puberty. Next, after puberty, the females has got menstrual cycle. Every month there is a cyclical changes in the ovary, in the uterus. with the culmination at the menstruation bleeding. This is called menstrual cycle. And out of 40,000, in each menstrual cycle, some 15 to 20 primary oocytes are chosen. Bakiguli remain dormant, arrested in the meiosis 1. Arrested and goes into the next phase. So at the start of menstruation, some 15 to 20 these primordial follicle with primary oocyte are chosen and goes into changes. What are the changes? Now look. This these are the single layer follicular cell become cuboidal. It was a flat, late becomes cuboidal and multi-layer. It a single layer chilo, it become cuboidal and multi-layer. It become multi-layer. Each cell become cubical. Name is changed now. Follicular cell we call now granulosa cell. And outside this layer there is an ovarian stromal cell. Ovarian connective tissue cell we call stromal cells. We call them granulosa cells. We call them granulosa cells. And this is the primary oocyte, chromosome number 46. We call granulosa cells. It is the granulosa cells. Gradually, menstruation period day 1, day 2, day 3 going on. সাধারণত আমরা menstruation bleeding থেকে স্টার্ট করি, তাহলে day 5, day 6, day 7, day 8 থেকে হচ্ছে। কেমন হলো? এইবারে খুব ভালো করে শোনো এটা। Gradually, and this is the cell membrane of the primary oocyte. Now we change the name of the cell membrane. We call vitelline membrane. The cell membrane of the oocyte is we call the vitelline membrane. Vitelline membrane. Vitelline membrane. And this cell of the oocyte and these granulosa cells gradually secrete a glycoprotein substance which cover the vitelline membrane. It is a glycoprotein made up of carbohydrate and protein. and it is secreted both by this follicular or granulosa cells as well as the oocyte. And the space between, and there is a space between this vitelline membrane and the this coating. এবার আমরা নামগুলি একটু একটু দেই। The cell membrane of the primary oocyte we call vitelline membrane. And this glycoprotein we called it zona pellucida. It is in the zona pellucida, right? And the space between this zona pellucida and the vitelline membrane we call perivitelline space. Peri mean around the vitelline membrane we call perivitelline space. And this is the granulosa cells. Now, this primary oocyte now is gradually increasing, and now it is called, the changes occur, we call it primary follicle. We call primary follicle. We call primary follicle. When follicular cells convert into granulosa cells, vitelline membrane is formed, zona pellucida is formed, we call primary follicle. From the primordial to primary follicle. But still the chromosome number is 46. Now is gradually end. Now next, some fluid-full spaces appear. Some cavities form full of fluid. Some cavity is formed with full of fluid. This fluid comes from the uterine wall, the ovarian wall, ovarian stroma, right? এই দেখো, বুঝতে পেরেছো? Fluid-full cavity appear, and gradually these fluid-full cavity join with one another except one region. When this fluid-full cavity appears, we call it secondary follicle. When small fluid-full cavity appear, primary follicle, now name is changed, we call secondary follicle. কি বলছি? Secondary follicle. এবং এইটাকে আমরা বলছি, after that the fluid full cavity join together to form a single cavity full of fluid, and this cavity we call antrum folliculi. Antral folliculi. And this follicle we call tertiary follicle. We call tertiary follicle. তাহলে primary follicle, primary oocyte, zona pellucida, granulosa cells. এই follicular cell. Then secondary oocyte, multiple layer of granulosa cells. Primary oocyte, when fluid appear and ultimately join together to form a single cavity, we call it tertiary follicle. Now, many ova try to develop, age bolechi, 15 to 20 over a primordial or primary follicular recruited, but only one of them, দৌড় যখন হয় একজনই ফার্স্ট হয়, only one of them quickly reaches maturity and quickly completes his first meiotic division and become half. Chromosome number is half. Right? একটাই পেয়েছে অথবা অনেক সময় দুটো পারে তিনটে যে quickly reaches the maturity and the chromosome number gets halved. Why chromosome number gets halved? Because it releases from the arrest in the prophase 1 of the meiosis 1 and completes its meiosis 1 and the chromosome number is halved. So what's happened when the chromosome number gets halved? But normally when cell divides, two cells form more or less equal in proportion, but no, here it is the difference. Only one cell becomes large, containing most of the cytoplasm, 99% of the cytoplasm, and other cell become very small, scanty cytoplasm and remain in the perivitelline space, and we call first polar body. So during meiosis 1, normally from one cell, two cells will be produced, but one cell becomes large and another cell is small, polar body. Number of chromosomes of this large cell koto hobe? 46 or 23? Koto hobe? Meiosis 1 এর পরে? 23. Polar body কত হবে? 23. And this, when the chromosome number become 23, we call it secondary oocyte. এতক্ষণ ছিল primary oocyte, we call it secondary oocyte. For MCQ, chromosome number of primary oocyte 46, chromosome number of secondary oocyte 23, and it is always 22 plus X or 22 plus Y? 22 plus always X, because it is a female. Right? And which attains the maximum maturity becomes very large, greater than 25 nm in diameter, even seen in the naked eye. We call it Graafian follicle. We call it Graafian follicle. পরীক্ষা অনেক সময় দেয়, draw and label the structure of a Graafian follicle. তখন কি লিখবে? Secondary oocyte, perivitelline space, polar body, first polar body, zona pellucida, and these granular cells surrounding these secondary oocyte, we call it cumulus euphoricus. Granular cell again divided into two parts. One cell surrounding the ovum, developing ovum, we call cumulus euphoricus. And এই granulosa cell কে আমরা বলি membrana granulosa, not very important. Now, before the Graafian follicle is formed, even in the secondary follicular stage, these outside connective tissue cells again divided into two layers. The inner layer we call theca interna, which secrete estrogen, and outside layer we call theca externa. Right? Now, at the middle of the ovarian cycle, at about 14th day or 15th day of menstruation cycle, it ruptures. This follicle pressure is very much increased, and this ruptures, and these secondary oocyte along with some cells of the cumulus umbilicus comes out from the ovary. Ovary থেকে ফেটে বেরিয়ে আসে। কি আসে? Secondary oocyte with some cells of the cumulus umbilicus, পুরোটা আসে না, some cell। এবং এটাকে তখন আমরা বলি করোনা রেডিয়েটা। কি বলি? করোনা রেডিয়েটা। তাহলে বাস্ট করে যখন এলো, তখন এলো সেকেন্ডারি oocyte with chromosome number half and corona radiata, right? Corona radiata কি? A part of the cumulus umbilicus surrounding the ovary, and it is taken up by the fallopian tube by transcoelomic migration and gradually reaches the ampulla of the fallopian tube by the coelomic migration and the contraction of the fallopian tube muscles, and it waits for spermatozoa to come to fertilize it. If spermatozoa fertilizes, when sperm enters the able to enter the secondary oocyte, then a calcium web starts and it completes its second meiotic division, and another polar body extruded in the polar says, and ultimately fertilization takes place. Otherwise, if fertilization does not take place, this ova will die within 24 to 48 hours. So complete the oogenesis. তাহলে কখন টোটাল মেয়োসিস কমপ্লিট হলো? অ্যাট দ্য টাইম অফ ফার্টিলাইজেশন। যদি ফার্টিলাইজেশন না হয় আর কিছু হবে না, ওই ফার্স্ট পোলার বডি নিয়েই থাকবে, আর না হলে হলো। সো দিস কমপ্লিট দ্য oogenesis, and quickly going to the spermatogenesis is not very difficult. This is an electron microscope. This is the oocyte. This is the Joda pellucida. This is the corona radiata cell. এগুলি তোমরা ফিজিওলজিতে পড়ো, অনেক টাইম দিয়ে নিয়েছি। অ্যান্ড এই যে রাপচার হয়ে বেরিয়ে গেল, and this part of the remaining part of the follicle, tertiary follicle, remain within the ovary, become corpus luteum. এই যে আর ছেড়ে দাও পরে। At the male it is a very easy process. Spermatozoa, quickly বলবো 2 মিনিটে, same thing happened, but the difference is that spermatogenesis male divided into two headings. Number one is spermatocytogenesis or spermatogenesis. Another next part is the spermiogenesis. Spermatogenesis, total development of the spermatozoa from the primordial germ cell to the final spermatozoa. But it is divided into 2 phases. One is spermatocytosis, another is the spermiogenesis. What is spermatocytosis? Where there occur the cell division and maturation. But spermiogenesis, there is no cell division. Each spermatid or final product of spermatocytosis matures and changes its shape to become final product, that is the spermatozoa. যেরকম প্রজাপতির পিউপা থেকে লার্ভা থেকে প্রজাপতি হয় চেনা যায় কি? Have you seen the larva of butterfly? দেখো আবার ট্যাটপোল দেখেছো ব্যাঙাচি? হ্যাঁ, ট্যাটপোল ছবি দেখেছো কি ট্যাটপোলের? ব্যাঙের থেকে ব্যাঙাচি যেমন চেনা যায় না, ট্যাটপোলটা মাছের মতো, লাইক এ ফিশ, অ্যান্ড toad is a different. But this one tadpole becomes one toad. Similarly, one spermatid becomes spermatozoa by changing its shape, its inner organelles changes. We call them spermiogenesis. Quickly chole jacchi. So primordial germ cell, like the female, at about 4th week of intrauterine life, gradually migrates to future developing gonads, and it becomes transformed in female primordial germ cell transformed into oogonia. But here it transforms, name is changes, it becomes spermatogonia and remain as such up to puberty. At the time of puberty, due to hormonal stimulation, these spermatogonia mitosis occur, cell division occur, and each spermatogonia become round shaped cell like the ovary, oocyte, but small. It is round shaped. Then it multiply and changes into dark. The cytoplasm when seen at microscope looks dark. খুব dark লাগে দেখতে. Dark type A spermatogonia. মাইটোসিস বলে একটা স্পার্মাটোগোনিয়া থেকে অসংখ্য ডার্ক এ টাইপ স্পার্মাটোগোনিয়া হলো। Then it again go mitosis. Some remain as a reserved cell from dark type A spermatogonia. Some cell the cytoplasm looks lighter, we call pale type A spermatogonia. So dark A type multiply, some cell remain as a dark type cell like a feature, act as a reserve, abar stimulate korle abar change korbe. Some cell changes takes place in the cytoplasm and slightly when seen under microscope it looks lighter. যেরকম সেরাস সেল মিউকাস সেল বলেছিলাম, যেমন মিউকাস সেল লাইট, সেরাস সেলগুলি ডার্ক, সেরকম pale type. Some of the pale type again by change division takes place and form type B spermatogonia. It occurs after puberty quickly. এগুলি মানে দ্রুত হচ্ছে, কত দ্রুত হচ্ছে আসছে। From the type B spermatogonia, it becomes primary spermatocyte. Again mitosis takes place and many type B spermatogonia, it changes into primary spermatocyte. Primary oocyte is present in female at birth, but in male primary spermatocyte only present after puberty. This primary spermatocyte then goes into meiosis and quickly completed meiosis 1. We call, then the name is changes, we call secondary spermatocyte. So after meiosis 1, the name of the primary spermatocyte we call secondary spermatocyte. So whether it is a secondary oocyte secondary spermatocyte. Whether it is a secondary spermatocyte, secondary oocyte, chromosome number is half, 23. কিন্তু এখানে কি প্যাটার্ন হবে? Sperm spermatocyte will be 23 plus X, secondary spermatocyte will be 23 plus 22 plus X or 22 plus Y. গেল? These secondary spermatocyte now form ultimately again completes its second meiotic division and forms spermatids. So spermatid এটার থেকে হলো secondary spermatocyte, তারপরে হলো final product of spermatocytosis is spermatid. Spermatid is a round cell with a nucleus, Golgi apparatus, mitochondria, everything, and look like a normal cell, round.